Hello everyone, welcome to Satya. Now we are here with the fifth part of Binomial Theorem. This is the last part of Binomial Theorem, and today we are going to discuss about Multinomial Theorems. First of all, what is a multinomial theorem? What is a multinomial expansion? We all know that binomial theorem means expansion or else an equation which consists of two variables whole power some number. Similarly, multinomial means as there are only two coefficients or else two variables, we named it as binomial. If there are more than three, x1 plus x2 plus x3 plus so on, xn or else xk whole power n. This is a multinomial expression, and multinomial theorem is mainly only for advanced. Mains do not concentrate on this. Let's see how to expand a multinomial expression. Let us assume this as a multinomial expression, and the expansion is summation of n factorial by alpha factorial, beta factorial, gamma factorial into x1 power alpha, x2 power beta plus so on, xn power k. So this is the way of expanding the multinomial theorem. It will be clear while doing problems. Now, finding number of distinct terms in a multinomial expansion. As we know that in a binomial expansion, if the power is n, we will take the number of terms as n plus 1, right? But in multinomial theorem, if at all x1 plus x2 plus so on, xr plus xn, xk, right, whole power n. If at all this is a multinomial expression, the number of terms after expanding it are, if the total x1, x2, x3, so on the terms are r, we take the number of terms as n plus r minus 1, c r minus 1. This is the way how to calculate the number of terms in a multinomial expansion. NCR minus 1, CR minus 1, where n is the power and r is number of terms in the bracket. Let's understand by an example. If 3x plus 4y minus 5z whole power, let's take 20. This is a multinomial expansion, right? As three terms are there. Find number of terms in the multinomial expansion. Now use the formula. N is 20 here. 20 minus r is 1, 2, 3. 3 terms are there in the bracket. So the value of r is 3. 20 minus 3, n plus r minus 1, right? 20 plus r minus 1, c r minus 1, 3 minus 1. 20 plus 3 minus 1, 22, c 2. After solving 22 factorial by 20 factorial into 2 factorial, 22 into 21 by 20 factorial into 2 factorial, 20 factorial, 25 gets cancelled, 2 ones, 2 11s, 21 times 11. Right, 231 terms are there in the expansion of 3x plus 4y minus 5z whole power 20. Nothing here, simply I am using the formula n plus r minus 1 cr minus 1. The only thing you have to find is what is the value of r and identifying the value of n. N is a power. Now next, finding the coefficients. We will understand this by an example. If 3x minus 6y plus 7z whole power 15. If they ask to find the value of, or else find the coefficient of x power 12, y power y square to z, 12 plus 2 plus 1. Observe here carefully. If they ask to find the coefficient of x power 12, y power 3, z power 9. First of all, check that all the sum of the powers x power 12, y power 3 and z power 9, 12 plus 3 plus 9 must be equal to the power. Okay? They will ask the coefficients of the expanded term in the binomial theorem. X power 12 into y square z power 1. Now add all the powers. 12 plus 2 plus 1 is equals to 15. First of all, before solving a problem, check whether the power sum is equals to n or not. If it is not equals to n, see 12 plus 3 plus 9 is not equals to n. What its value? 24, right? 24 is not equals to 15. So, the coefficient of x power 12, y power 3, 2 power 9 in the multinomial expression is 0. Because there will be no term x power 12, y cube, z power 9 in the expansion of this multinomial. Now, this is our question. X power 12, y square, z. So, this is our question. We have to find the coefficient of x power 12, y square, z's coefficient. Okay. For this, remember a formula. For some time, forget the question. No. X plus y plus z whole power 20. Let's take this and now, or else let's take n only. X power alpha, y power beta, z power gamma, where the condition is alpha plus beta plus gamma must be equal to n. Then only this exists in the expansion of this multinomial theorem. So, now the coefficient will be n factorial by, so the powers are there, right? Alpha factorial into beta factorial into gamma factorial. This is the coefficient of x power alpha, y power beta, z power gamma of this multinomial theorem. Now let's do the problem. See what we required, the coefficient of x power 12, y square and z. And the value of n is 15. So the coefficient will become 15 factorial by x power is, we took in the we took there as alpha and here is 12. So 12 factorial into 2 factorial to 1 factorial. So this is the coefficient of x power 12, y square into z. If at all there is 7, 4, 4, then automatically denominator part changes to 15 factorial by 7 factorial into 4 factorial into 4 factorial. And similarly, if we take 4, 4, 3, How to write 15 factorial by 4 factorial into 4 factorial into 3 factorial? Is it right? No. This is wrong. So the sum of 4 plus 4 plus 3 is not equals to n. So be careful. Only when the sum of powers are equals to n, then only we will write the formula 15 n factorial by alpha factorial into beta factorial into gamma factorial. And next, finding the coefficient of an expansion x power alpha, y power beta, z power gamma in the multinomial expression of. See here now, there are the coefficients kx plus k1x plus k2y minus k3z whole power n. Now, for finding these kinds of coefficients, first of all, for every problem we have to check that whether alpha plus beta plus gamma is equals to n or not. This is the first condition we have to check. If this is not satisfying, then the coefficient will become 0. And now, if it satisfies, then the coefficient will become n factorial by same alpha factorial into beta factorial into gamma factorial. And the extra we will get is there are k1, k2, k3 as coefficients of x, y, z. So we will get k1 power alpha as x power alpha is there and coefficient of x is k1. We get k1 power alpha and y is, and for y k2 power beta, for z is minus k3 power gamma. So this is the way how we should calculate the coefficient of any multinomial term. There are two formulas left over, which is sum of indefinite series 1 minus x whole power minus p by q. How to expand these kinds of expressions? Just remember the formula. It is easy. 1 plus p by 1 factorial x by q whole power 1 plus p into p plus q whole power divided by 2 factorial into x by q whole square plus so on p into p plus q, and the next term is, we will write the next term for more clarity, p into p plus q into p plus 2q by 3 factorial into x by q whole cube and so on. And similarly for 1 plus x whole power minus p by q, the expansion is 1 minus p by 1 factorial into x by q plus p by 2 factorial into p plus q into x by q whole square plus, minus p into p plus q into p plus 2q by 3 factorial x by q whole cube plus so on. These are the two formulas you have to remember. So here is a problem related of sum of indefinite series, and we have to find the value of 7 by 5 into 1 plus 1 by 10 square plus 1 into 3 by 1 plus 2. So we have clarity that the expression is going to obtain will be in the form of 1 minus q, 1 minus x whole power minus p by q, right? As we discussed before, 1 minus x whole power minus p by q. Now, see what is the expansion? 1 plus p by 1 factorial x by q plus p into p plus q by 2 factorial to x by q whole square plus so on. Now, compare these two. What is the value of p here? From here 1, 1. 1 plus 1 by 1 fact p by 1 factorial into x by q. So p, what is the value of p here? P is equals to 1 and the value of x by q is equals to 1 by 10 square. Now see the next one, 1 into p plus q. So from here we get p plus q is equals to 3. We have the value of p as 1. 1 plus q is equals to 3, q is equals to 2. Now we got the value of q. Put it here so that we get x. X by 2 is equals to 1 by 10 square, x is equals to 2 by 10 square. So these are the values. We have the value of p, the value of x, the value of q. That's it. Substitute here 1 minus 2 by 10 square whole power minus p is 1, q is 2, power 1 by 2 into 7 by 5. Don't forget this, into 7 by 5. 7 by 5 into 10 square, 100 minus 2, 98 by 100 whole power minus 1 by 2. Minus 1 by 2 means it gets inverse. 7 by 5 into 10 by root 98. 5 ones, 5 twos, 7 into 2 by root 98. In area root 98 is 49 twice. Root of 49 is 7 into root 2. 7 cancel and the answer is root 2. See, this much big expansion, but the answer is root 2. Got it? Just we compare the formula, we have 1 minus x whole power minus p by q to the question. Hope you understand. That's it for today. Please like, share and subscribe Satya's channel. If there are any comments or suggestions, please drop them in the comment box. Thank you.